Okay, so now we've created our circuit. Now let's look at how we can simulate that. But before we do that, I just wanted to show you how we can open the circuit again after we've closed it. So I've come to the file where I've saved my circuit, and like I said in the previous video, I'm going to click on this OPJ type file. Just going to double click, and that should open up my Capture CIS with our circuit there. The one thing that is maybe a little awkward at first is this is going to throw you into the start page. Well, we don't want to be in the start page. We want to be at the circuit we just opened. And that's not a problem. All we're going to do is we're just going to select a different tab along here on the top once everything finally loads. So again, keep in mind you do need to be connected to Milligan's server in order to use PSpice. Okay, so as promised, it's put us in here to the start page, but we don't want to be here. We want to come to our bridge circuit. And there's our circuit that we created last time. So if we want to simulate this, what we're going to do is come up here and select New Simulation Profile. And so notice right now we don't have a simulation profile, so a lot of these other options about running a simulation, viewing results, and editing the profile are all grayed out. So first we need to create a simulation profile. And so let's say we want to do some DC analysis. And so what's going to happen if I try to name it this is it's going to get upset because I have a space in the name. So it's telling me I have to have an alphanumeric and only underscores or hyphen. So I can fix this just by replacing our space with an underscore, for instance. So now it's going to bring up a menu, and we're going to be able to set up our profile. So at any time, we can come over here to General on the left and change the name of our profile. But most of what we're going to be doing is going to be in this Analysis tab. So in our Analysis tab, the main thing we want to do is select our analysis type, and then from there we're going to have different options for the rest of the setup. So if we're just doing a DC analysis where nothing is changing, we're not changing any variables during the simulation, we're actually going to want to select bias point. You might think we're doing a DC analysis, well, let's choose DC sweep because it has DC in the name. And that would be incorrect because what a DC sweep is doing is it's saying, let's take this voltage source or this current source that's DC, and let's start it at some point A. Let's say our voltage source starts at 10 volts, and then let's step it by 1 volt increments. So 10, then 11, then 12, then 13, up to some endpoint. And so what it's going to do is simulate it at each one of those points. But because we're not doing that, we just have a static circuit where nothing is changing, we're going to select bias point. We don't have quite as many options here as we did with that previous analysis type, and in general for this bias point, we're not going to worry about it. We can just leave things as is. So we're just going to go ahead and click OK. And so now we have a simulation profile, and these items up here are no longer grayed out. So let me go ahead and click to create a new simulation profile again, and let's say maybe we're going to change out sources and we're going to do some AC analysis on this source later on. And so for the AC analysis, we would want either this time domain transient or AC sweep noise, depending on exactly what we're doing. We're going to see in some later videos exactly what we need to set up here, but for now we're just going to have sort of a placeholder simulation profile. So now that we have two, we can see from this drop-down menu, we can select between all the profiles we've created. So what that means is that we can do multiple different types of simulations on the same circuit. So in this case, we want to stick with our DC analysis, so I'm going to select that one. And to run the simulation, I'm going to click Run PSpice. And so it's going to tell us it's working on it. We had this little window down here where it's telling us the process. If we have any errors, that's going to come up in that window or any warnings. And if you do have anything you run into that's giving you trouble, just let me know and we can try to figure it out. Because PSpice often can be pretty finicky. Okay, so we run our simulation and we get this new window that's popped up with our results. So notice 100% complete with our simulation, yet we don't have anything in this window. And so the reason for that is it essentially defaults to the page where it shows data over time. And so because we don't have anything to plot, it's just grayed out. So what we can do though is we can go to this view simulation output file. So this little magnifying glass over the page. So if we click that, we can see some basic info about our circuit. So here we have our different parts. We see we have a voltage source labeled V1, our resistors R1 to R5, and the different nodes that they're connected to, and some other info there. By default, it's also going to give us our node voltages. So we have node N00163, and we have 50 volts there. Node N00176, 36.8590, and then we have this last node here as well. It's also going to give us by default information for currents in our voltage sources and the total power dissipated in the circuit. Okay, so what are these weird numbers for our nodes? I don't remember putting in N00176 anywhere. So let's go back to our circuit for a second to investigate. Okay, so if I hover over any of these points, these wires, what I'm going to see is I have this N00163 come up. So what that means is this whole top node is our node N00163. Over here, this is our node N00190. Over here is N00176, and down here where our ground is connected is just 0. So we can make our life a little easier by using something called a net alias. So if we come over here to this icon and click it, or if we use our keyboard shortcut N, we can put in net alias. So let's say we want to call this node 1 at the top instead of the N00163. This is another area where you don't want to have any spaces in your names. And when we come to place this, we want at least one of these lines of a box to be blue such that it's touching the node that we want. So we see it's touching the node on the bottom there, so we're going to click to place it, and that's our node 1. And I'm going to click escape to stop. So now if we hover over this, we see that this node is now called node 1. So we can do a similar thing for our node 2 and our node 3. So I'm going to do N as a shortcut for that. So notice it's kind of guessed what I was going to do. It's moved on to node 2. And so we can connect to that. We just want to make sure at least there's a little bit of blue area there overlapping. It didn't really go for some reason. There we go. So it's connected to that node. Escape to stop. In node 3. Okay. And let's connect that here like that. And then escape to stop. So now notice we just have node 3, node 2, and node 1. So that's a lot easier to see. So I'm going to run the simulation again. No errors in our report down here. Notice because I didn't close that window, it's just over here. It's not popped up. It's just rewritten our output. And so this looks pretty similar. The main difference now is that for our node voltages, we have them labeled as node 1, node 2, and node 3, as opposed to those seemingly random numbers. And so if we compare this to our nodes, we see that these are in fact the same node voltages that we saw for in our bridge circuit. But let's say we want to go find the power for that 20 ohm resistor. So let's go back to our circuit again. And so what we can do now is if we're just doing a bias circuit, what we can do is we can use these toggles to show our voltage, our current, and our power. So if we're interested in power, we can click on this W, which of course stands for watts. We see it's now blue square around it indicating it's on. And we see our R4 has 67.93 watts. And so that also agrees with what we found in the notes, as we would expect. Notice it's positive, indicating that power is being consumed by the resistor, also like we would expect, whereas over here, our source has a negative power because it is supplying power. We can just toggle that by clicking again to turn it off. We can also turn on the current if we were interested in the currents in any of these components. Turn that off, and then we could also turn on our voltages to see that directly here as well. So here we see our 3 node voltages and our ground is 1. We can turn all of these on at once, but of course it gets pretty clustered. As we are looking at different types of circuits which have different sources or different things varying over time, we can also use these probes here. And we also have some parts in our special library called iPrint and vprint2, and so these can also be used to print our current or our voltage into this output file. One thing to note though is our iPrint, we essentially treat it like an ammeter, so we would connect that in series, and our vprint, typically you want to use this vprint2, and you would connect that in parallel just like a voltmeter. But for most cases, we're not going to really need to use any of those. We'll see in later videos how we deal with calculating values and plotting different things. Okay, so that's all for our basic introduction to PSpice. So this should be enough to get you started on Lab 1, but of course, we're going to go through a lot more different functions of PSpice as the semester goes on.